Hello. In this video, we're going to look at long division of polynomials. So before we do that, I'm actually going to show you um, one of the division algorithms for real numbers and how that can apply to a polynomial that is related. And then I'm actually going to show a second division algorithm that we can use for polynomials. We can use it for numbers as well, although the modification that it requires for numbers is a little bit tricky. But starting with what's a fairly commonly taught division algorithm in North America, if I want to divide 174 by 11, I have 174 divided by 11. Now, there's other division algorithms that organize how they're writing things a little bit differently, but the principles are essentially the same. It's a three-step process. We're going to divide, we're going to multiply, and then subtract. So I start by dividing however many digits I can. So I'm going to start, for example, here by focusing on the 17, which is actually 170. And so what I'm actually asking myself is how many times does 11 go into 170? But what I can really do is how many times does 11 go into 17? And it does go one time. Now, this is in the tens place. So what I'm actually saying is that 11 can go into 170 10 times. Now, obviously, it can go more. But if I'm just dealing with this place, this is what I'm dealing with. So that's the first step, is start at the left of your number and divide it by your divisor. The 11 here is the divisor. All right, the 174 is the dividend. Just for vocabulary purposes, the answer will be the quotient, and I will have a remainder here. So 1 times 11 is 11. Now, remembering that this is actually 10 times 11, so it's 110. So that's the multiplication stage. And now we do our subtraction, and this is so we can find out how much is left. So what's our remainder? So realistically, I'm subtracting 110 here, although I don't have to write the 0 there. And what I'm left with is 64. Now, I know I've done my subtraction right, because until I write this 4 here, just 6 doesn't contain another 11. If I did that subtraction and I got something bigger than 11, then I would have to modify this 1, this quotient that I've written up here. But I have 64. Now I ask myself, how many times does 11 go into 64? And it will go completely 5 times. So I'm repeating those steps. I'm dividing again. We divide, then we multiply, then we subtract to find out what's left, and then we repeat those same steps. So 64 divided by 11 is 5. I now multiply 5 times 11, which is 55. And once again, we're at our subtraction stage. 64 minus 55 is 9. So 9 is our remainder. Now, if I were going into decimals, I could carry on. I could put 0 here, 0.0, and this becomes 9.0, and I can go from there. That is certainly something that is useful with numbers, but it is not what we're going to do now, because our point here is to divide polynomials. And with polynomials, we can't really go into decimals. So we need to think of this then as, so vocabulary, this was the dividend. The 11 is the divisor. The 15 that I've now received, that's the quotient. And the 9 is my remainder. So we often will say that this is 15 with a remainder of 9, but I can actually express that as a fraction as well. So this enables me to express this as a mixed fraction. 174 over 11 is therefore equivalent to 15 and 9 11ths. I am going to actually write this as 15 plus 9 11ths, which is essentially what a mixed fraction means. It's one of the very few instances in math where no symbol means addition as opposed to multiplication. But I'm going to write that there because with polynomials, we don't have the option of leaving out the plus sign. So the answer to this division is the quotient plus the remainder divided by the divisor. So in a lot of ways, this division that I've written off here to the right, x squared plus 7x plus 4 divided by x plus 1, is exactly the same division that I've just done. In fact, if x were equal to 10, it would be the division I've just done. So I can consider this to be sort of written out where the x squared term, the quadratic term, is the 100ths place. The linear term, the 7x, is the tens place, and the x in the numerator, or denominator, sorry, is the tens place. And then I have my constants, which are the ones place. So I'm going to express this in a very similar way for the division. my dividend, x squared plus 7x plus 4, divided by the divisor of x plus 1. And then I do the same 3 steps over and over again. So I start by dividing, then I multiply, which is going to involve the distributive property, and finally I subtract. The nice thing here is it's actually easier than it often is with numbers because I don't really need to respect how many digits stay in each place. I can have 2 digits in one place. So I start with the term farthest to the left in the dividend, and I divide it by the first term in the divisor. So x squared divided by x is x. I'm going to line that up with the other linear term in the dividend. So x squared divided by x is x. And now I'm going to distribute when I multiply. So I'm going to multiply that x by both parts of the divisor so that I can figure out what my remainder is, what's left. So this gives me x squared plus x. My next step is to subtract. I do have to remember to distribute that subtraction. So I have x squared minus x squared, which is gone. 7x minus x is 6x. And then this was again a plus 0, so I can subtract 4 minus 0. You don't have to write this plus 0, so I'll put it in red, but this now is 6x plus 4. So that's what I have left over, and I can divide again. So I now take 6x divided by x, which is 6. I do have to put a plus sign, so plus 6. Now I'm going to distribute that 6 to both parts of the divisor, so 6 times x is 6x. 6 times 1 is 6, so plus 6. And finally, I'm going to subtract. So I need to subtract both parts, 6x minus 6x. And then 4 minus 6 is negative 2. So my remainder is negative. That's fine, no problem with polynomials to have negative terms. That would obviously be an issue with my 174 divided by 11. But I actually kind of want to think about this because remember I said that if x was equal to 10, this would be equivalent. And what we have is 15 plus 9 11ths when we divided 174 by 11. In this case, this would sort of be equivalent. So it's x plus 6 minus 2 over x plus 1. If x was equal to 10, then what this would be giving me is 16 minus 2 11ths, which we certainly wouldn't do with fractions, but it is actually equivalent to 15 plus 9 11ths. So this division, x squared plus 7x plus 4 divided by x plus 1 is equal to x plus 6 minus 2 over x plus 1. This form will be useful for some of the graphing that we want to do later. So being able to divide this polynomial will come in handy when we start wanting to graph functions like this, in calculus especially, but a little bit before we get to calculus. Now, if you've learned an alternate division algorithm, so it's organized differently than this, it still does involve those 3 basic principles. So it involves dividing, then multiplying, then subtracting to figure out what's left, and then repeating that process over and over again. And certainly that algorithm can be modified to adjust for polynomials as well. I'm going to show a different way of organizing the division. It does involve those same 3 steps, but some people find it a little easier to organize. I like it because it doesn't end up using as much space on the page, but it's essentially, I'm going to use boxes. Along the left-hand side of these boxes, I'm going to put the terms of my dividend, so 2x and 3. So in this case, I need 2 rows because I have 2 terms in my dividend. If I had 3 terms in my dividend, I would need 3 rows. We're not going to ask you to do that very often, but it could happen. What I need to think about for number of columns is what degree do I expect my quotient to have? So if I'm dividing a cube by something linear, degree of 3 divided by degree of 1 is going to give me degree of 2. So I need to have an x squared term. I need to have an x term. I need to have a constant. And then I'm going to have, just kind of off to the side, it's not really its own column, I'm going to have a remainder. So this one is going to be 3 columns plus an extra space for the remainder. Now I'm not going to completely populate this square to start, but what I am going to do is I'm going to take that first term. That first term is going to go in the top leftmost box. So 8x cubed. And what I'm now going to do is I'm going to divide. So remember, the steps of my division algorithm are to divide first, then multiply, then subtract. So I'm going to take my 8x cubed and I'm going to divide it by 2x. And what I get is 4x squared. So 8x cubed divided by 2x is 4x squared. Now I'm going to multiply that 4x times 3. When I multiply 4x times 3, I get 12x squared. Notice that I don't have 12x squared in my polynomial, I have 10x squared. So what I'm going to do is on diagonals, I'm going to figure out what other term do I need so that together they would give me 10x squared. And that would be negative 2x squared. I need a negative 2x squared here in order to get 10x squared when I put those together. So that's basically my subtraction step because it's 10x squared minus 12x squared. I don't necessarily have to think about it as subtraction, but it is what it is. Then I repeat. So negative 2x squared divided by 2x is negative 1x. I don't have to put the 1, so it's just negative x. Next, I multiply. So I'll do that one in green. Negative x times 3 is negative 3x. Bearing in mind that I want negative 9x. So again, on diagonals, what would it take so that these two terms together would be negative 9x? Well, I would need a negative 6x here because negative 6x minus 3x is negative 9x. Repeat the steps yet again. So negative 6x divided by 2 is minus 3. And finally, we multiply. Negative 3 times 3 is negative 9. And once again, on the diagonal, I don't want negative 9. I want plus 8. So that's going to take a 17 here because 17 minus 9 would give me 8. And that is my remainder. So what this means is that 8x cubed plus 10x squared minus 9x plus 8 divided by 2x plus 3 would equal, this is the quotient. So we have 4x squared minus x minus 3 plus the remainder over the divisor. So 17 over 2x plus 3. So just to kind of give the general form of this, we have some polynomial divided by a divisor is going to equal the quotient plus the remainder over the divisor. That's the form that I've given here. There is an alternate form we sometimes write this in because it's equivalent to say that if I were to multiply this back out, so if I were to multiply 4x squared minus x minus 3 times the divisor, 2x plus 3, I would then add the remainder on, and that would return me to my original 8x cubed plus 10x squared minus 9x plus 8. So this form that I've written this in is essentially that the quotient times the divisor plus the remainder equals that numerator polynomial. All right, we're going to do one more example, and I will show it in both algorithms. So initially, I'm going to show it in the boxes. So I have a divisor with two terms, so I need two rows, x and 5. I'm dividing a square by a linear. So dividing a square by a linear means I'm going to have a linear answer. So I need an x term and a constant, and then I need space for my remainder. I put the first term in the first box on the top left. Now I divide. 2x squared divided by x is 2x. Now I multiply. 2x times 5 is 10x. On the diagonal, I'm looking to make my linear term. Notice I don't have a linear term here. So it's like I have 0x. So in order to have 0x, I need a minus 10x to make that work out. Now I divide. Minus 10x divided by x is minus 10. Minus 10 times 5 is negative 50. On this diagonal, I need to make minus 9. So this would be plus 41 to make the minus 9. So 2x squared minus 9 over x plus 5 is equal to 2x minus 10 plus 41 over x plus 5. If I wanted to do that in the other division algorithm, I need to have a placeholder for that 0x. So I have 2x squared minus or plus 0x minus 9 divided by x plus 5. So I need a placeholder there so that I have a linear column here to line stuff up. All right, my three steps. First, I divide. 2x squared divided by x is x. Line that up in the linear column. Now I distribute. It's 2x. 2x times x is 2x squared. 2x times 5 is 10x. I subtract, which means I'm subtracting both terms. So the 2x squared now disappears. 0x minus 10x is negative 10x. So notice we're ending up with a lot of the same things. We're just organizing them in a different place. Now I also am going to bring down the minus 9. Minus 10x divided by x is minus 10. Distribute that. Minus 10x minus 50. When I subtract, I'm subtracting both terms, which means I'm turning them both into pluses. The negative 10x plus 10x is going to disappear, and minus 9 plus 50 is 41. Same remainder I got in the previous example.